Hello guys, welcome to this electrical interview preparation session. In the next few minutes, we will cover important components frequently used in electrical system. Circuit breakers, phase sequence relays, overload relays, contactors, timer relays, and fuses. Please do not forget to like, share, and subscribe. Let's get into the video. The first question, what are the main types of circuit breakers and briefly explain them? Circuit breakers protect electrical system by interrupting current flow during faults. Common types include MCCB, which is a miniature circuit breaker, is an automatically operated electrical switch that protects a circuit from damage caused by overcurrents like an overload or a short circuit. Unlike fuses that must be replaced, an MCCB can be manually reset after it trips, making it reusable and more durable. MCCBs are essential safety devices for residential, commercial, and industrial electrical systems. It uses two main mechanisms to detect faults. For detecting short circuits, a magnetic coil generates a strong magnetic field when there is a sudden high surge of current. This field instantly triggers the trip mechanism to shut off the circuit. And for detecting overloads, a bimetallic strip heats up from continuous excessive current. When it bends enough, it activates the trip mechanism to break the circuit. When the MCCB trips, it opens the circuit to stop the flow of electricity, preventing potential hazards like fires or equipment damage. After a fault is cleared, you can manually reset the MCCB by flipping the switch back to the on position. An MCCB or molded case circuit breaker is an electrical protection device that safeguards circuits from overloads and short circuits by interrupting the current flow. Its name came from the insulating molded case that houses its internal components, and it's used for high current rating and large electrical systems such as those found in industrial and commercial buildings. MCCBs protect electrical circuits, cables, and loads from damage caused by overcurrents, such as those from overloads or short circuits. They are used in application that exceeds the limit of smaller circuit breakers like MCCBs and can handle a wide range of voltage and currents up to 2500 ampere or more. For protecting overloads, a thermal element, which is a bimetallic strip, bends when hit by a sustained overload current, triggering the tripping mechanism. And for protecting short circuits, a magnetic element, which is solenoid, is activated by the sudden high surge of current during short circuit, causing an instantaneous trip. An ELCB, which is earth leakage circuit breaker, is a safety device that protects against electric shock and fire by detecting and interrupting dangerous electrical currents that leak to earth. It does this by monitoring for an imbalance between the current flowing into the live and neutral wires, or by detecting stray voltage on equipment enclosure. The ELCB constantly monitors the electrical circuit for any current that is flowing to the ground through an unintended path, such as a person or a faulty appliance. In a healthy circuit, the current flowing back through the neutral wire should be equal to the current flowing out through the live wire. If the ELCB detects an imbalance, it means current is leaking to earth. It then automatically trips the circuit, cutting off the power supply to prevent electric shock and potential fires. After tripping, the ELCB must be manually reset to restore power to the circuits. The second question, what does a phase sequence relay detect? A phase sequence relay detects an incorrect phase sequence in a three-phase system power supply, which can cause a motor to run in the wrong direction. It also monitors for phase loss, a failure in one or more phases, and a phase imbalance, which is unequal voltage level between the phases, to protect equipment from damage. It ensures that the three phases, line 1, line 2, and line 3, arrive in the correct order. If the sequence is wrong, the relay trips to prevent the motor from starting, avoiding damage and protection in the reverse. It detects if one or more of the three phases are missing from the power supply. It can detect if the voltage in the three phases are not equal, which can cause a motor to overheat or malfunction. The third question, what is an overload relay? An overload relay protects an electric motor and its component from damage caused by excessive current, which can lead to overheating. It does this by monitoring the motor's current draw and, if a continuous overload is detected, signaling a contactor to open the circuit and shut off power. An overload relay protects an electric motor and its component from damage caused by excessive current, which can lead to overheating. It does this by monitoring the motor's current draw and, if a continuous overload is detected, signaling a contactor to open the circuit and shut off power. Overload relays also protect against issues like phase loss or imbalance. It prevents the motor from overheating and damaging its windings due to drawing too much current for too long. The relay continuously monitors the current flowing to the motor, detecting when it exceeds a safe predetermined threshold. When a prolonged overload is detected, it sends a signal to the contactor, which then opens the main power circuit, stopping the motor. Overload relays can also detect or protect against other dangerous conditions such as three-phase motor losing one of its phases. The fourth question, what is a contactor used for? A contactor is an electrically operated switch used to control high-power electrical loads by safely switching circuits on and off. They are commonly used for industrial applications like starting electric motors, but also control other high-current systems such as lighting, heating, and high-voltage AC equipment. Contactors are often used as motor starters, which connect or disconnect an electric motor from the power supply. They are used to switch large lighting installations on and off, especially in commercial and industrial settings. Contactors also control other equipment like heating elements, capacitor banks, and other large electrical loads. They allow for the remote operation of electrical equipment by using a low power control signal to switch the high power circuit. When combined with other devices, contactors can provide safety features such as short circuit protection, overload protection, and undervoltage protection. The fifth question, what is a timer relay? A timer relay is an electrical device that controls the switching of a circuit based on a set time delay. It combines an electrical relay with the control circuit to automate tasks by turning a circuit on or off after a specific interval, which can be initiated by a signal or when a power source is applied. These devices are used in many applications for tasks like starting motors, turning on lights, and synchronizing operations. An electric or mechanical circuit within the relay receives trigger signal or input power to start timing sequence. Once triggered, the relay waits for a present adjustable time period to elapse. After the delay is complete, the internal relay contacts open or close to switch the connected electrical load. The sixth question, what's the function of fuse? The function of fuse is to protect electrical circuits and equipment from excessive current by acting as sacrificial safety device. It contains a thin wire that melts and breaks the circuit when the current exceeds a safe level, preventing damage, fire, and electric shock. Once a fuse blows, it must be replaced to restore power to the circuit. Under the normal conditions, the fuse allows electrical current to flow through it without issue. If a fault like a short circuit overload occurs, the current increases dramatically. The excess current generates heat, which causes the fuse's internal wire to heat up until it melts. The melted wire breaks the circuit, stopping the flow of electricity to device or wiring it protects. The seventh question, what is an off delay timer? An off delay timer delays the deactivation of a circuit after the input signal is removed. When the input signal is turned off, the timer starts a countdown and the output remains active for present period before it switches off. This is used for delayed stop applications such as allowing a cooling fan to continue running after a motor has stopped. An off-delay timer's primary function is to keep a circuit on for a set amount of time after the power input signal is turned off. A common example is ventilation fan in the bathroom or a cooling fan on a machine. The fan stays on for a few minutes after the light is switched off or the machine is shut down to ensure proper cooling or air circulation. The opposite of delay is an on delay timer, which delays the start of a circuit after a signal is applied. An off delay timer delays the stop of a circuit after the signal is removed.